All right, welcome to the Explainer. Today, we're going to pop the hood on AI. We're not just talking about what it can do, we're asking, how does it actually run? Let's get into the engine room and see how these things really work.
So let's just dive right in, because this is a question I bet you've thought about. These AI models are getting ridiculously smart, right? But using them can feel kind of slow, and it's definitely expensive. What's the deal? Well, the answer reveals the single biggest challenge in AI today, something called the compute paradox. And this paradox, it's the central problem that everyone, from the biggest tech giants to the smallest startups, is trying to crack. You've got all this incredible intelligence, but it comes at this absolutely massive computational price. It creates something engineers call a memory wall, and it's this huge bottleneck that just chokes performance, no matter how beefy your GPU is. And it all boils down to the very specific way these models think. Okay, so here's the two-step dance that causes all the headaches. Step one is called prefill. This is where the model just inhales your entire prompt all at once. It's super fast, very compute heavy, and it gets all the context it needs. But then comes step two, the decode stage. And this is where everything grinds to a halt. The model generates its answer one single word at a time. And this process is painfully slow, and it absolutely hammers the system's memory. So get this. Here's the real kicker. The system has no idea if the AI is going to spit out one sentence or a 10-page essay. So it has to block off a huge amount of memory just in case. And the result? As this quote points out, memory utilization is often under 20%. That means we are literally throwing away over 80% of our super expensive GPU memory. It's just sitting there, doing nothing. This is where the real war for optimization is being fought. So how do we fix this insane wastefulness? Well, the fight is happening in the cloud on a massive scale. Right now, in the data centers that power all the AI tools we love, two titans are battling it out to solve this memory crisis. Meet vLLM and SGLang. First up, let's talk about vLLM. They came out with this absolutely brilliant idea called PagedAttention. What is it? The best way to think about it is like the virtual memory in your computer's operating system, you know? The thing that keeps your computer from crashing when you have 50 tabs open. They basically built that, but specifically for the AI's brain. It's short-term memory. It chops up the memory into these small, easy-to-manage pages or blocks. And you can really see the difference here. On the left, that's the old way. It's a total mess. It's fragmented, wasted memory with all these huge empty holes. But on the right, that's vLLM's PagedAttention. It's clean, it's organized, and it only uses memory when it's absolutely needed. The efficiency is just incredible. And the results? I mean, they're just staggering. Memory waste just plummets, going from something like 60 to 80% all the way down to less than 4%. I mean, that's a total game changer. It made it possible to serve way more users at once, which makes AI services cheaper and faster for all of us. Okay, so vLLM is great for raw speed. But what if raw speed isn't the whole story? What if what you really need is smart speed, especially for complex stuff like a long back-and-forth conversation? Well, this is where a new contender called SGLang steps into the ring, arguing for a much more intelligent approach. SGLang's secret sauce is called RadixAttention. It's super clever. Instead of just managing memory, it actually remembers conversations. Think of it like this. If you're having a long chat with an AI, SGLang doesn't have to reread and reprocess the entire conversation every single time. It just finds where you left off and reuses what it already knows, completely skipping that expensive prefill step. And this table really lays out the trade-offs perfectly. Look, for just raw throughput, handling tons of different requests, vLLM is still the king, about 10 to 15% faster. But then you look at SGLang, and wow. For interactive chats, where the time to that first word really matters, it's almost 4 times faster. For making sure you get perfectly structured JSON data, 3 times faster. And it does all this using almost half the memory. So what this really boils down to is their core philosophy, right? vLLM is trying to be the jack of all trades, a powerful, universal engine that can handle anything you throw at it. SGLang is more like a specialist. It's designed to understand the logic of your program so it can hyper-optimize for those really complex back-and-forth tasks. All right, let's shift gears completely. We've been up in the massive cloud data centers, but now we're coming back down to earth, right to your own computer. Because while those titans are fighting it out in the cloud, there's a quiet revolution happening on our desktops. And this whole revolution is being fueled by a format called GGUF. And the magic here is just pure simplicity. It takes everything the model needs, the weights, the tokenizer, all the metadata, and packs it all into one single file. That's it. The whole AI model is just one file you can download and run. And of course, someone had to make it easy to use these files, right? So two amazing tools have popped up, both built on top of the legendary llama.cpp project, Ollama and LM Studio. But they're for very different kinds of people. Okay, so the easiest way to think about these two is like this. Ollama is for developers. It's a command line thing that just runs in the background. Seriously, it's like Docker, but for LLMs. Then you have LM Studio. That's for everyone else. It's a beautiful app with a UI. You can search for models. It's literally an app store for LLMs.
And this chart just nails the difference. You look at Ollama, it's all about the command line, automation, APIs, stuff developers love. LM Studio, it's all about that graphical interface, the GUI. It's for people who want to explore and experiment visually, using simple sliders and dropdowns instead of writing a bunch of code.
All right, we've met the cloud titans, vLLM and SGLang. We've seen the desktop heroes, Ollama and LM Studio. So, which one is right for you? Well, as you've probably guessed, it all comes down to what you're trying to do. It's about matching the tool to the task.
Okay, scenario one, you're building a massive public API that has to serve thousands, maybe millions of users. You need rock-solid stability and maximum throughput. Your weapon of choice? vLLM, no question. Its batching capabilities are just built for that kind of scale.
Scenario 2, you're building a really smart chatbot, an AI agent that needs to remember long conversations and has to spit out perfectly formatted data, like JSON, every single time. Here you need speed and precision. You go with SGLang. Its RadixAttention makes conversations feel instant, and its decoders ensure your data is always perfect.
Okay, let's bring it back to your laptop. Scenario 3, you're a developer. You just want to plug an LLM into a script or some internal tool. You want it to be easy, and you need an API. You're going to use Ollama. The one command to run setup is just too good to pass up. It's built for this.
And finally, scenario 4. You're not writing code. You're just exploring. You want to try out a bunch of different models, play with the settings, and see what happens. Your perfect tool is LM Studio. It's a visual playground. You can download models with one click, tweak everything, and just experiment. So, what's the big takeaway from all of this? It's that the whole idea of finding one best engine is, well, it's over. We're moving away from a one-size-fits-all approach. The future is all about scenario-specific optimization. The best tool is going to be the one that was specifically designed to solve your exact problem. And that leaves us with a really fascinating question to chew on, doesn't it? As these incredible tools for both the cloud and the desktop get better and better, that line between them is just going to get blurrier. So where is your next AI going to live? Is it on your phone, in the cloud, or maybe in both places at the same time? The future isn't just about what AI can do, but where it does it.